6,000 worlds discovered, billions more waiting. The greatest journey may begin with simply learning how to look. The question is no longer simply, are there other worlds? We know there are. The question is, what will humanity learn from them? Them exoplanets, and each one represents something extraordinary. Another planetary experiment, another world, another possibility. Some may have oceans, some may be frozen, some may be worlds of fire, some be like anything or life.
This is the revolution. Astronomy is moving from asking, does a planet exist, to asking, what is happening there?
Look at these atmospheres: water, methane, oxygen. We're seeing weather patterns.
The era of exoplanet exploration has truly
By studying
begun.
the light passing through an exoplanet's atmosphere, scientists can search for water vapor, carbon dioxide, methane, and other chemical. These clues may eventually help us understand whether life can exist elsewhere. But the search for life is only the beginning. Exoplanets can also teach us about ourselves. For the first time, humanity can compare Earth with thousands of other worlds. Why did Earth develop oceans? Why did our atmosphere become suitable for complex life? Why did biology emerge here? And what conditions allowed intelligence to develop? Other worlds may reveal possibilities that nature never created on Earth. Extreme temperatures, different atmospheres, different chemistry, different planetary architectures. The universe is showing us that Earth is not the only way to build a world. And someday, these discoveries could become more than scientific knowledge. They could become destinations. A spacecraft leaves the solar system. These discoveries could become more than scientific knowledge. They could become destinations to worlds beyond our dreams, where new horizons gleam. The first travelers to another star may not be human. They may be machines. Autonomous spacecraft capable of traveling for decades, studying distant worlds, analyzing their atmospheres, and searching for resources. Approaching an alien planet, they could become humanity's scouts. Our eyes beyond the solar system, our first explorers of another planetary system. We're learning what worlds are made of, what they need to remain stable, what happens when stars change, and perhaps what conditions allow civilization to survive.
The data shows promising patterns.
Let's run the simulations. Planetary resources, solar energy, space habitats, robotic mining concepts, interstellar spacecraft, humans looking through a massive space telescope. We cannot currently travel to most exoplanets, but studying them today prepares us for tomorrow. The technology developed to discover distant worlds is already improving telescopes, sensors, artificial intelligence, spectroscopy, spacecraft, and communications. Every distant planet becomes a lesson. And perhaps the greatest lesson is this: Earth is not simply a place where humanity lives. It is our first experiment in planetary civilization. Somewhere among those stars are worlds we have not yet discovered. Worlds with oceans we have never seen, skies we have never breathed, mountains we have never climbed, and perhaps life we have never imagined.
Welcome to the Gallery of Human Sustainability. Today we'll look into how black holes, mysterious compact objects in the infant universe, may be part of the evolutionary chain that produced enormous cosmic structures, and eventually the environments where life became possible. There is an important update to the description. The newest result reported on August 13, 2026 concerns an object called MOEM BH1. It is described as the most distant black hole star candidate yet. It is seen less than 660 million years after the Big Bang. The object was discovered by astronomers using NASA's James Webb Space Telescope JWST as part of the Mirage or Miracle MOEM survey. The research involves stars studying the earliest black holes, galaxies, and the mysterious little red LR. A related and important JWST investigation was led by Vasily Kokorev of the University of Texas at Austin. His team studied another LRD, glimpse 17775, and found more than 40 spectral lines providing strong evidence for the black hole star interpretation. NASA and ESA describe this as some of the strongest evidence yet for the model. Astronomers found MOEM-BH1, an extremely distant object that appears to be dominated by a rapidly growing black hole surrounded by material that makes it look somewhat like a star. It is important to clarify the terminology, then lapidal start of reckoning a black hole. Important to clarify the terminology, black hole star does not mean a normals containing a black hole. Instead, the proposed structure is approximately black hole, habitability falling gas, and doesn't emit light. The enormous brightness comes from material falling toward it and releasing gravitational energy. Why are the little red dots so important? JWST discovered large numbers of these compact reddish objects in the early universe. They are called little red dots because that is essentially what they look like in Webb images. Black holes. Their nature has been debated. Possibilities have included young galaxies, dense stellar systems, rapidly growing black holes surrounded by extremely dense gas, combinations of black holes and stars. Increasingly, observations are supporting the idea that at least some LRDs are rapidly accreting black holes hidden inside dense gas.
And NASA's June 2026 analysis of glimpse 17775.
Including evidence from hydrogen, oxygen, helium, and an iron forest of spectral lines. Fascinating, so they're hidden in plain sight. Black hole problem. Astronomers have observed very massive black holes surprisingly early in cosmic history.
If black holes began from relatively small stellar remnants, they would have had a difficult time growing to billions of solar masses so quickly.
Exactly. Our models suggest sustainability principles could provide the missing mechanism. This chart shows a possible pathway for black hole formation.
It begins with an early black hole seed.
Then rapid gas accretion forms a dense cocoon. This creates a black hole star or little red dot.
It grows into a quasar, then a supermassive black hole.
This is one possible unproven pathway. Why does MOEM-BH1 matter so much? It appears to be close to a young galaxy,
And simulations show a merger in 100 million years.
providing a connection, isolated star to galaxy merger.
To a little red dot-like phase and a growing black hole. Incredible.